everyone, and welcome to Sally and Bytes. Today, I am here to teach Chapter 8, Tuples in Python, Part 1, for the Class 11 students of Computer Science. In this video, we are going to discuss about Introduction to Tuples, tuple creation, nesting of tuples, accessing and traversing a tuple, and practical implementation. So let's dive in and get started. Let's learn about tuples in Python. What do you mean by the term data structure? A data structure is an efficient way to organize and store data or information. We have learned that lists are data structures that store related data items. Now, we are going to discuss on another Python sequence, tuples. Tuple is a data structure in Python that allows you to store multiple values together as a single entity. It is another sequence data type that is similar to the list. It is an ordered collection of elements. It consists of multiple values in a single variable separated by commas and enclosed within parentheses. Example: open parentheses, red comma blue comma green close parentheses. The values that make up a tuple are called elements. Tuples allow duplicate values. Tuples are heterogeneous, that means, tuples can contain elements of different data types. For example, a tuple can have a mix of integers, strings, floats, or other data types. The syntax of tuple is, tuple underscore name or variable name equals open parentheses, value 1 comma value 2 comma up to value n, close parentheses. For example, fruits equals apple, strawberry, grapes. In this example, we have a tuple named fruits, with 3 elements, as apple, strawberry and grapes. The elements in a tuple are addressed using their index value. The index value of tuple starts with 0. The main difference between lists and tuples are lists are enclosed in square brackets and their elements and size can be changed, while tuples are enclosed within parentheses and cannot be updated. Tuples are thought of as read-only lists. Let's see some examples. Example 1. Variable tup1 holds a tuple with elements of different data types, a string, an integer, a float, and another integer and printed. Output is a tuple holding Sally and Bytes, 20, 40.05, 250. Example 2. Variable tup2 holds an empty tuple is printed. Output is empty tuple. Example 3. Variable tup3 holds a tuple defined without using parentheses, with 4 integer elements and printed. Output is a tuple holding elements 20, 40, 60, 80. Example 4. A variable tup4 holds a nested tuple containing 2 tuples as its elements and printed. Output is a nested tuple inside a tuple holding elements 10, 20, 30, 40, 50, 100, 150, 200. Example 5. A variable tup5 holds a nested tuple with a tuple and a list as its elements and printed. Output is a nested tuple holding a tuple and a list 20, 40, 60, 80, tuples in Python. Example 6. A variable tup6 holds a tuple containing 2 lists as its elements and printed. Output is tuple holding 2 lists 2, 4, 6, 1, 3, 5. Each tuple is printed to show its contents. Note that each output is enclosed within parentheses as it represents a tuple. Let's learn about singleton tuple. When creating a tuple with a single item in Python, you need to include a trailing comma after the item to differentiate a tuple from a parenthesized expression. Example, my_tuple equals 42. In this example, my_tuple is a tuple with a single item, the integer 42. The trailing comma after the item distinguishes it as a tuple. Without the comma, it would be interpreted as just an integer value. It's important to note that if you don't include the trailing comma, Python will treat the item as the data type itself, rather than a tuple containing that item. Let's see some examples. Example 1. In this example, my_tuple is defined as a tuple with a single item, the integer 42. The trailing comma after the item ensures that it is recognized as a tuple. When printed, the output shows 42, indicating a tuple containing the value 42. Example 2. In this example, my_tuple is assigned a single value, the integer 42. However, since there is no trailing comma, Python interprets it as an integer rather than a tuple. When printed, the output is simply 42, representing the value of the integer itself. You can check the output and find the difference. Tuples are immutable, that is, we cannot change the elements of a tuple in place. We cannot perform insert, update and delete operations on them. An attempt to modify an element of a tuple yields an error. Let's see some examples. Example 1. In this code, we first define a tuple called my_tuple with 3 elements, 1, 2, and 3. The elements are enclosed in parentheses and separated by commas. This tuple is assigned to the variable my_tuple. Then, we use the print function to display the value of my_tuple on the console. So the output is a tuple holding 1, 2, 3. Example 2. In this example, my_tuple is initially defined as a tuple containing the values 1, 2, and 3. When we attempt to modify the value at index 0 by assigning a new value, 10 in this case, a type error is raised. This error occurs because tuples are immutable, meaning their elements cannot be changed once they are created. The immutability of tuples ensures that their values remain constant throughout their lifetime. If you need to modify a collection of elements, you would typically use a mutable data structure like a list instead. Let's see how to create a tuple. To create a tuple in Python, you can use parentheses, that is, round brackets, and separate the elements with commas. Round brackets indicate the start and end of the tuple. Syntax is tuple_name or variable name equals value 1, value 2, up to value n. Let's see an example of a tuple with mixed data types. A variable tup1 holds the tuple containing a string, integer, and float values and printed. So the output will be a tuple holding the elements pen, 10, 50.0, enclosed within parentheses and separated by commas. Let's see how to create a tuple using built-in function tuple. An empty tuple can be created using tuple function. In this example, the tuple function is used without any arguments to create an empty tuple. The empty_tuple variable is assigned the result of the tuple function, which is an empty tuple. When we print empty_tuple, the output is an empty pair of parentheses, indicating that it is indeed an empty tuple. Note that you can also create an empty tuple using empty parentheses, directly, like this, empty_tuple equals empty pair of parentheses. Let's see how to create tuple containing string values using built-in function tuple. Let's see some examples. Example 1. In this example, tup1 is created by passing the string computer to the tuple function with a trailing comma. The tuple function treats the string as an iterable and creates a tuple where each character becomes an element of the tuple. When print of tup1 is executed, it outputs computer, which represents the tuple containing individual characters from the string. The type of tup1 statement returns class tuple, confirming that tup1 is indeed a tuple. Example 2. In this example, tup2 is created by passing a tuple, red, blue, green, directly to the tuple function. The tuple function accepts an iterable as an argument and creates a new tuple with the elements from that iterable. In this case, the original tuple, red, blue, green, is already a tuple, so it is returned as it is. When print of tup2 is executed, it outputs red, blue, green, representing the tuple with 3 elements. The type of tup2 statement returns class tuple, confirming that tup2 is indeed a tuple. Both tup1 and tup2 are tuples, but the way they are created differs. Tup1 is created by passing a string to the tuple function, while tup2 is created by passing a tuple to the tuple function. Let's see how to create a tuple with a single element. To create a tuple with a single element, you have to include the final comma. The final comma after single value is mandatory, otherwise it is not considered as tuple, rather treated as a character or a string or an integer. Example 1. In this example, tup1 is defined as a tuple with a single element, the string bytes. The trailing comma after the string ensures that it is recognized as a tuple. When type of tup1 is executed, it returns class tuple, confirming that tup1 is indeed a tuple. Example 2. In this example, tup2 is assigned the string bytes without the trailing comma. Without the comma, Python interprets it as a string rather than a tuple. Therefore, when type of tup2 is executed, it returns class str, indicating that tup2 is of type string. To create a tuple with a single element, it is important to include the trailing comma, even if there is only one item. This is to differentiate it from other parentheses-based constructs and ensure that it is recognized as a tuple. Let's see how to create tuple by accepting user input using while loop. Example 1. Line 1. Here, you initialize an empty tuple named tup using the tuple function. This creates an empty tuple with no elements. Line 2. This line prompts the user to enter the number of elements they want in the tuple. The input function accepts user input as a string, and int is used to convert it into an integer. Line 3. This line initializes a counter variable I to keep track of the number of elements entered. Line 4. This starts a while loop that will iterate as long as I is less than or equal to n, which represents the desired number of elements. Line 5. Inside the loop, the program prompts the user to enter a number for the tuple. The input function is used to accept user input, and the entered value is assigned to the variable a. Note that the input is treated as a string. The input function always returns a string. Line 6. The entered value, a, is appended to the tuple tup using the plus operator. The comma after a ensures that it is recognized as a tuple with a single element. The result of the concatenation is assigned back to tup, updating the tuple. Line 7. After appending the element to the tuple, the counter I is incremented by 1 to move to the next iteration. The loop continues until I reaches n plus 1, meaning the desired number of elements have been entered. Finally, after the loop completes, the program prints a message tuple created and then displays the created tuple by printing the variable tup. Now, look at the output. User enters 3 elements, 20, 40, 60. The tuple created is a tuple holding strings 20, 40, 60. Let's discuss about the nesting of tuples. Nesting of tuples refers to the concept of having tuples as elements within another tuple. In other words, a tuple can contain other tuples as its elements, creating a nested structure. Let's see an example. In this example, tup1 and tup2 are 2 individual tuples. Then, a new tuple tup3 is created with tup1 and tup2 as its elements. So, tup3 becomes a tuple that contains 2 nested tuples. The output shows that tup3 is 1, 2, 3, A, B, C, indicating that tup3 has 2 elements, where each element is a tuple. The first element is the tuple 1, 2, 3, and the second element is the tuple A, B, C. Nesting of tuples allows us to organize and represent complex data structures within a tuple. It provides a way to group related data together and create hierarchical structures. You can access the elements of nested tuples using indexing or slicing, just like with regular tuples. Let's see an example. Write a Python code to create a nested tuple to store roll number, name, and marks of students. Now, look at the Python code. Line 1. In this line, a nested tuple stud is defined, containing student information. Each nested tuple represents the information of a single student, consisting of 3 elements: roll number, name, and marks. Line 2. This line prints the column headers for the student details table, including serial number, roll number, name, and marks. The values are separated by tabs, \t, to align them in a formatted manner. Line 3. This line starts the for loop that iterates over the range of indices from 0 to the length of the stud tuple. This loop will iterate for each nested tuple in stud. Line 4. Inside the loop, this line prints the student details for each nested tuple. I+1 represents the serial number, which is obtained by adding 1 to the loop index I. Stud of I of 0 accesses the roll number of the student in the current nested tuple. Stud of I of 1 accesses the name of the student. Stud of I of 2 accesses the marks of the student. The elements are separated by tabs, \t, to align them in a formatted manner. This output displays the student details in a tabular format, with each student's information on a separate line. The columns include the serial number, roll number, name, and marks. You can check the output on the console. Let's learn about accessing and traversing a tuple. A tuple is a sequence of values which can be of any data type, and they are indexed by integer. Accessing elements by index. Individual elements of a tuple can be accessed by using square brackets and the index of the element to be accessed. The index starts from 0 for the first element and goes up to len of tuple -1 for the last element. Accessing elements using negative indexing. Python also supports negative indexing, where -1 refers to the last element, -2 refers to the second last element, and so on. You can look at the picture. A tuple holds elements 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Elements of a tuple can be accessed using an indexing method. The individual elements of a tuple can be accessed through their indexes given in square brackets. Tuple indices start at 0. The tuple index must be a positive or negative integer value or an expression which evaluates to an integer value. Positive value of index means counting forward from beginning of the tuple. And negative value means counting backward from end of the tuple. Let's see some examples. Example 1 on the first white box. Accessing elements by index. You can access individual elements of a tuple using square brackets and the index of the element you want to access. The index starts from 0 for the first element and goes up to len of tuple -1 for the last element. In this example, we access the first element of my_tuple using my_tuple of 0, the output will be 10, and the third element using my_tuple of 2, the output will be 30. Example 2 on the second white box. Python also supports negative indexing, where -1 refers to the last element, -2 refers to the second last element, and so on. This can be useful when you want to access elements from the end of the tuple. In this example, we access the last element of my_tuple using -1, output displayed is 50, and the third last element using -3, the output displayed is 30. Example 3 on the third white box. Traversing elements using a for loop to iterate over the elements of a tuple, you can use the for loop. The loop variable will take each element of the tuple one by one, allowing you to perform operations on them. This loop will iterate over each element of the tuple my_tuple and print them on separate lines. So the output will be 10, 20, 30, 40, 50 on separate lines. Example 4 on the fourth white box. If you know the number of elements in the tuple and want to assign them to separate variables, you can use tuple unpacking. Assigning variables in this way allows you to access individual elements easily. Here, we have unpacked the elements of my_tuple into variables A, B, and C. Now, we can use these variables to access individual elements of the tuple. So the output displayed will be 10, 20, 30. Let's see some more examples. In this code, we have a tuple my_tuple with 5 elements. We use the len function to get the length of the tuple, which is the number of elements in it. In the first part, we use the range function with lenof, my_tuple, to generate a sequence of indices from 0 to len of my_tuple -1. Then, we iterate over these indices using the for loop and print the corresponding element from the tuple. The output displayed will be 10, 20, 30, 40, 50, printed on separate line. In the second part, we use a while loop with an index variable starting from 0. We print the element at the current index and increment the index by 1 in each iteration. The loop continues until the index reaches the length of the tuple. The output displayed will be 10, 20, 30, 40, 50, printed on separate line. Both approaches will traverse the tuple and print each element on a separate line. Thanks for watching. Watch the upcoming videos. Chapter 8, Tuples in Python, Part 2. Tuple operations, tuple slicing, tuple concatenation, tuple replication, membership operator in and not in, comparing tuples, deleting tuples, tuple functions and practical implementation. You can check the link in the description box below.